Who are we even? What are we even doing here?
Who are these guys?
Yeah. Well, since you're the host, why don't you go first?
All right. We are Americans. We are Californians. We are practically family by our connections to my cousins,
Yes.
who are your close friends.
Yeah, the Luddington family are some of my best friends. We've known each other since high school.
Awesome. So when I was living in Sacramento, I was going over to visit my cousins at their house, where I met Phil. And it's like instantly I ignored all my cousins and just launched into hours-long conversations with Phil because we instantly clicked and have so much similarity in our wavelengths, in our thinking about philosophy and psychology. So we instantly hit it off. And now here I am in Thailand, and Phil is in California still.
Yep, currently in Chico.
Chico, and we recently got back in touch, and our our natural conversations were just like, I at least realized that it's too much, it's too wasteful to have an audience of two in our phone call conversations. So I thought we need to start recording this stuff. So that's the inspiration or the idea behind how this started up, I guess.
So what is your educational background?
All right, thanks. I have a PhD in psychology, cognitive psychology from UCLA. I've
Very
been
nice.
teaching psychology in Thailand, in Bangkok, Thailand, at the university called Chulalongkorn University. And now I'm doing online teaching because of COVID. All right. And so, Phil, what did you study?
Well, I went to PUC, majored in psychology, and I also have a landscaping business on the side, which caused me to want to add landscaping as a major. So I switched colleges to go to Andrews University to double major, and I received my bachelor's of science in psychology and a bachelor's of technology in landscape design. I've been making most of my income through landscaping, but I spend all of my free time just reading and studying philosophy and watching lectures on YouTube and just trying to stay up to date because I have future aspirations to go back to graduate school. Not sure when that's going to happen. I'm still deliberating about which schools I should go to and which program I should do.
Yeah, do you know which kind of program you might be interested in?
I'm interested in neuropsychology, areas like clinical counseling. It would be fun to be a Jungian psychotherapist. I'm still deliberating about all those options.
Okay, right on. So that's a little bit about us. All right. Okay, so we're gonna try probably to make our shows 40 minutes long to fit the Zoom default limit for a free account. And our topic, I don't think we're even gonna get much time to get into it, but our first topic that we wanted was randomness.
Yeah, that's been a puzzle on my mind for a while now.
I think we should at least broach the topic.
Yeah, like my thought was, oh, oops. Sorry, I dropped my phone. Okay.
That was totally random.
Yes. So is it possible that what I just did is completely random? No.
That's a good intro.
uh, on a more intentional note, um, I always wondered, because I had a problem with this idea of an infinite regress, because if you commit to the idea of a deterministic system, doesn't that also leave you with the problem of an infinite regress of trying to explain the cause that caused the previous effect and so on, turtles all the way down? That seems unacceptable to me. And so I'm thinking, okay, what are the two options? At the risk of claiming a false dichotomy, the two options I see are determinism and randomness. Um, I'm not sure what it would look like to have a mix of the two, because they seem mutually exclusive. If something is completely random, wherein could them? In completely deterministic, where's there room for randomness? And so I think a lot in philosophy hinges on this problem. Um, uh, at least topics like free will isn't affected either way, I would say, because no amount of mixing of free will or no amount of mixing randomness or determinism will get you free will. But I started thinking more about randomness. Um, and I just defined it myself, because there's lots of confusion mixing like chaos theory with that, which is not true randomness. I wanted something that was truly random in a way which is acausal, can theoretically behave in self-contradictory ways, is basically unpredictable to an omniscient mind. Like, is there anything like that in reality?
Ooh, good definition. Unpredictable to an omniscient mind. That also is a paradox, because omniscient means all-knowing.
Yeah.
So is it possible for a mind to be all-knowing and still unable to know what's coming next?
Right. So essentially, randomness should be impossible to create an algorithm for.
Good point.
And I'm wondering,
Whoa.
does such a thing exist in any conceivable universe in any sense? And that's a puzzle I've been thinking about for years. And I don't have any final answer to it, but I have some interesting thoughts about it.
Wow. You see, just like we talked about the beginning, the keystone, or no, the concept of the paradox.
Yes.
And here's a paradox. We've stumbled on one, like you just dug straight down to it. The paradox of, can randomness actually be programmed? No,
Right.
it can't. If it can be programmed, then it's not random, right?
Well, yeah, because you know what its nature is. Like pi, for example, is an irrational number whose digits are indefinite, and by all accounts, the distribution of digits look completely random. But I don't think pi counts as true randomness in this case, because it describes the shape of a circle, which is an ideal figure, which isn't random.
It's mathematically precise.
Right.
So
But what's interesting to note about the random string of digits in pi is that if you were to correlate each number from 0 to 9 to a letter of the alphabet, like say you go from 0 to 9, which is 10 different digits, and do the first half of the alphabet, the first 10 digits of the alphabet, and then do the next 11 through 21 digits. Like, I guess you have to do some double mapping of the numbers, but basically if you correlated letters of the alphabet to numbers, essentially contained within pi is all possible knowledge, every book ever written, every idea that could ever be uttered. But that is all a result of just the random strings of digits producing a parrot order.
right, it's the concept of monkeys on a keyboard. Uh,
Yeah.
eventually, if you have enough monkeys slapping keys on a keyboard, eventually they will accidentally type like
Shakespeare.
Shakespeare, that was it, yeah.
Yeah, it's basically the law of large numbers.
Right. Yeah. Yeah, and I was just
Anything
thinking,
that can happen will happen
what can happen will happen.
if given enough time and possibility. Because randomness is essentially sheer possibility, if you wanted to define it in one word.
Yeah. So let's get back to this paradox. If randomness can be programmed, it's not random. If it can't be programmed, then where on earth did it come from?
Well, there's also the problem that if we think we've observed something random, we can't ever know for sure if it is random, because someone could accuse us of committing the incredulity fallacy and just
Ooh,
simply not having enough information to confirm if it truly has no algorithm to describe it.
I see.
And so there is an actual empirical issue with actually discovering randomness. But I think if we get into the foundations of number theory and Gödel's incompleteness theorem, there seems to be reason to think that there are true statements which cannot be proven. And that kind of leaves us to try to infer the existential state of randomness as best we can.
Is that Gödel's incompleteness theory, that we can never prove? Sorry, can you describe it?
As the best I can remember is that Gödel's incompleteness theorem states that there is no set of real numbers which can contain all sets, including itself. There's always some recourse to a larger set which subsumes the sets above it. And so there's a grounding problem wherein there is no set which can contain itself included.
I see.
And so we know that mathematics is profoundly powerful, yet there is this fundamental grounding problem that you can't use mathematics to prove its own validity. It's merely asserted. It's merely asserted as an axiom.
I see. Every discipline, every field is founded upon principles or axioms that they cannot prove. They cannot. Math is the perfect example. Math cannot prove itself true. It all starts with assumptions.
Yeah, I guess
Faith.
the value of any given method is in its ability to get predictive results. Just the basic philosophy of science, Karl Popper's falsifiability principle. Like, even if you don't have a solid foundation for something, does your method still result in having predictive, replicable, and reliable results?
Yeah, I see that. So the value is not whether or not something can be, a field can be proven beyond of a shadow of a doubt that it is absolutely true, but rather, does a field or discipline demonstrate value, predictive value, utilitarian value?
At least on an empirical, methodological, naturalist perspective, the results and reliability are more important than its existential grounding, or than its epistemological grounding. Although it's ideal if you can ground things as rigorously as possible.
Absolutely. So at an absolute level, nothing can be absolutely proven. Everything rests on at least certain small measures of unprovable aspects.
Seems like it. I think Descartes' uh, famous saying, "I think, therefore I am," like the subjective first person experience of consciousness seems to be a self-evident proof of itself. Um, so
Yeah,
phenomenology seems to be its own proof. Um,
yeah. That's a good critique. Can you explain that critique?
well, it's possible to doubt everything. Okay, what did Descartes do? He tried to doubt as many things as possible until until he found something he couldn't doubt, and then he would try to use that one thing to build a philosophical system from that first principle. And
But it
it
sounds
could be
like you
possible.
it sounds like you doubted even that. Or you expressed at least some reason to be skeptical about even that, the I think therefore I am.
Do you mean that wait, what do you mean?
I
That
mean,
I'm not,
is that sufficient for you? I think therefore I am. Is that a proof? Is that
well, let's see.
Are you satisfied with that? Is that a real proof that you are?
Huh. Well, thinking seems to be separable from consciousness itself. And so I'm not sure that, okay, the one thing that I think I cannot doubt is consciousness, that it is like something to be me. It is possible that my thoughts and the way I use language to describe things could be a more illusory phenomenon, but I'm at least certain of the self-evident experience of my own consciousness.
Right on. Well said. I think that's more precise. The I think therefore I am is very simple, very easy to remember too. But I think what you just said
Mhm.
is more precise. It's a little more wordy, so it's not as catchy, but
Yeah,
but what you're saying is I am conscious, therefore at least consciousness exists.
yeah,
I mean, you have to have consciousness to be conscious of consciousness. So at least consciousness exists.
yeah. I mean, it sounds like a tautological statement,
It does
but
sound tautological. Is that a
but
problem, maybe?
I'm not sure because here we are talking about it. Um, I don't know. I kind of closed the loop on the Ouroboros there. I think I glitched my brain out trying to try, trying to unpack the self-evident nature of self-awareness.
I think
It's
maybe about half of our viewers' brains just exploded. Pop.
yeah. Well, I hope not.
Don't leave us.
If that happened to any of you, you should probably see a neurologist.
You may have blown a blood vessel or two.
Yeah. So
That's what we aspire to do on this show, is to explode blood vessels. So
yes, let's cause as much neurological damage to our viewers as possible.
uh,
Okay,
but
so
yeah,
I was playing.
yeah.
I was playing with the idea that what if paradoxes or apparent paradoxes are actually portals in a way to a higher paradigm, which, like a keystone, can explain the the paradoxes that you were dealing with before in the lower paradigm. Because Einstein once said, a problem cannot be solved from within the same paradigm in which it was conceived. And so if you seem to have an irresolvable problem, that's actually a hopeful indication that you're on the verge of a breakthrough to a higher paradigm. Now, the question is there a limit? How many paradigms can you go up? Like, once you've left Plato's cave, are you just in a bigger cave that you also have to figure out how to leave? Like, is it like a cosmic onion? You can never leave Plato's cave. But at
Ooh,
least in terms of being sane, leave the cave that you're aware that you're in. And when
good.
when when you realize that you have a paradox, it means you're in a cave.
Yeah. Oh, good.
So
Well said. If if
so it's good when you find paradoxes.
if there's an apparent paradox, you're in a cave. Because paradoxes are, well, they're paradoxes. They shouldn't exist. Paradoxes are not supposed to exist. I mean, how
Right.
can something be and not be at the same time? It troubles the brain at least. Uh,
Because and here's another thing. If we assume that paradoxes are unacceptable, like in reality there is no such thing ever as a paradox, then what do you do if you start experiencing that as you're ascending levels of paradigms and you keep encountering paradoxes and that causes you to realize there must be a higher paradigm? Is there an indefinite layering of paradoxes? Like, if there's an infinite number of alleged paradoxes, isn't that itself a paradox? And this leads me back to the question of maybe true randomness does exist, because if it did exist, it would reduce the pressure on so many different philosophical issues. Like, for example, if if the world is completely deterministic, I already said we have an infinite causation problem, a regress problem of causation. But if randomness is a possible principle, then we already discussed that randomness could include order. When we talked about pi, for example, you can have all the books ever written contained in the irrational digits of pi. And so maybe if the fundamental nature of the universe, or at least the origin of the universe, was in true randomness, it could be that because all possibilities are contained within that, including a unification of opposites, then contained within randomness is the possibility for order. So we may,
wow.
in some sense, be existing in a neighborhood of ordered digits, or digits with apparent order, in a larger context of randomness.
Oh, wow.
Um,
Beautiful. So you're saying that order may be a subset of randomness
yes,
because
and I
randomness,
think
order, we know, order is something finite. We can point to it. It's concrete. Whereas
yeah,
randomness is really abstract. It's almost like randomness is almost unmanifest because anytime it manifests itself, it's now concrete. It's now something to point at.
yeah.
Uh,
I think the concept of randomness seems to share a lot of qualities in common with other spiritual disciplines I've been researching. Like in the Gnostic tradition, they have this emanationist theology wherein all the gods and everything in creation emanate from what's called the pleroma, which is the unification of all opposites in this chaotic field, which cannot be comprehended. Um,
hmm.
eh, the personification of the pleroma is this not well known deity called Abraxas, who is the personification of sheer effectiveness. And then you can divide Abraxas into positive and negative effectiveness. The positive effectiveness includes Yahweh. The negative effectiveness is described as Satan in the Gnostic understanding of things. And from God comes all of creation, etc. And so then we have that world. Then there's the Taoist world, where they're the equivalent of what we're talking about in randomness could be the Tao, also translated as the way. where when they write in the Tao Te Ching, it says the name which can, what was it? The thing
The
which
Tao
can be,
that can be named is not the Tao.
exactly, yeah. And that speaks to the idea of anything which can be given an algorithm is not random.
Oh
Or
yes, exactly. Good.
and so there's this concept not only in that, but there's in Taoism, there's also this idea of the yin, which is a unification of chaos and order in one single circle. And what if they are right and the universe really is fundamentally made up of a combination of chaos and order, and apparent order is an emanation from a background chaos, which also fits in with what Jordan Peterson likes to reference with the story of Marduk confronting Tiamat. And so it really could be that we use language, or we use our reality filtering lenses to extract the order out of chaos that we can live in. But I kind of went all over the map there. But
That was awesome.
I'm
You covered a lot. You touched on a lot of topics that I feel like we're gonna keep coming to these things over and over, I'm sure.
yeah, we'll get more and more articulate about them too, I hope.
Can you kind of
But
make a recap more concise? I to help me out, to maybe help the listener out. Like, what are you saying? Are you saying
okay,
that order comes out of chaos? Can you say it?
yeah, I'm saying that randomness contains within itself the possibility for order. And so randomness as a entire principle contains the concepts of chaos and order within itself. And it is from that which anything that exists now can emanate from.
Wow. Ah, I see. Because even chaos, I used to think that chaos was randomness, but I don't think so now. After this conversation, I don't think so. I think that chaos and order are these two. I don't know if it's fair to call them archetypes, but
They're fundamental irreducible realities. It's impossible to describe something which doesn't fall in the category of chaos and order.
right.
And that's why it's an archetype.
Oh, bravo. Wow. Thank you, Phil. So these two archetypes emanate from randomness, is what we're saying, theoretically.
Yeah, that's a possibility.
Right. And then if that's the case, then chaos isn't randomness. Chaos comes from randomness, but it's not randomness itself. Chaos is defined by its by differentiating
Well,
itself from order.
yes, in insofar as it is not order, or okay, to the degree that it is not ordered, it is increasingly chaotic.
Yeah.
And so we have chaos theory as a rigorously defined discipline within mathematics, where there's a system of variables where any change to one variable has drastic effects to all the other variables in the system. So you may have heard of the butterfly effect, where if a butterfly flaps its wings in the rainforest, it can cause a hurricane somewhere on the other side of the world because of the interrelated nature of the planet.
Yeah.
It may be an exaggeration that a butterfly could do that, but chaos is essentially we have a very finely tuned system wherein change to one variable affects the others drastically. And so it, by human standards, is essentially unpredictable, but in theory, it is predictable because you can create an algorithm for it. So it is therefore not completely random.
Ah, right. I see. Oh. So, okay. So are you speculating that chaos is not random?
I would say so. Yeah. If you use the
Whoa.
mathematical conception of chaos, it is not random. Only true randomness by definition is truly random. But chaos has its own specific definition that you can work with
Like
rigorously in mathematics.
chaos can be modeled.
Yes. Like in thermodynamics, atoms scattering about in a container, like atoms of gas in a cylinder, they're behaving chaotically. It is technically possible to predict the location of every particle in there. It's not practically fun to do that, but you could do it.
Interesting. Okay. So if order and chaos are archetypally are distinguished from each other, and chaos can be described mathematically, and order could be described and explained and accounted for, then order and chaos are really just two sides of the same coin. There
I
maybe
think
there is
so.
no paradox after all
I
between.
have a I have a drawing depicting the yin yang. There's a little thing I drew here,
Oh, that's
and
beautiful.
I was trying to unify as many religious concepts in one symbol as possible, but that's not the point for this conversation. So what I wanted to point out is that
Oh, that's
what if
awesome. Yeah. Okay.
the Paisley, okay, so as you get more chaotic, like the black is chaotic, there is increasingly less order. But
Yeah.
as the black part gets thinner and thinner, correspondingly, there's even more order. And so as you approach infinite chaos, you achieve total randomness.
Yeah.
But it's also possible to achieve infinite order, and that is also an apparent contradiction with total order. So total order and total randomness, if one or the other Paisley takes over, is itself a paradox that is unified in this circle.
Oh, I think I get it, because you cannot have order without chaos or chaos without order, because one is always defined with regard to the other. You can't
Yeah,
say chaos if there is no such thing as order.
right. Yeah, it wouldn't make sense. Like chaos in reference to what
Yeah.
exactly?
Yeah.
Because if you're complaining that something's chaotic, it means you think that it should be less chaotic, which implies that that's a possibility.
If there were no chaos in the world, it wouldn't make sense to talk about order.
No, because there's only one conceivable reality you can ever talk about. It's impossible to think that there could be something outside of it if there's only that thing.
Exactly. Like a fish doesn't talk about loving to breathe water. That's all it ever does. That's all it ever sees. It's all it ever floats in. So it doesn't talk about water. If we lived
Right.
in a world, in a universe of perfect order, we couldn't talk about order,
Hmm.
because there would be no chaos to distinguish order from.
Yeah.
All right. So we have
Right.
these two things, order and chaos, and they are mutual. They seem
They're complementary
they're
to each
complement.
other
Thank
in a
you.
way that as you increase in order, chaos diminishes, and as you increase in chaos, order diminishes. And so the idea with that symbol is that you need to achieve a perfect balance, but that perfect balance itself is like a, have you ever experienced a glitch in a video game where like there's two flickering screens that are like vying for screen attention? Like it's like shifting between, like it's glitching between black and white. Like what would it be like if it was like exactly between, like if you switch the light on and off, but what is between that? That
Right.
is an undefinable state. There's no state between on and off that you can describe linguistically. And
Yeah. And I just thought of like between positive and negative numbers in math, there's what we call imaginary numbers.
Yeah, that's definitely beyond my realm of competence
Same
to
here. Like,
describe
what are they?
imaginary.
They're imaginary. They don't exist.
Yeah, all the mathematicians in the audience will probably be, they have a lot of things to say about that,
Yeah,
I bet.
yeah. The lack of defining is troubling. Lack of
Yeah.
being able to define. But
Well,
I'm
there's permanent categories of knowledge. Like there's the known known, the known unknown, the unknown unknown, no, the known unknown, and then the unknown unknown. And that last category is a permanent category. There will always be the unknown unknown. But does
oh,
that category also extend to an omniscient being? Like,
mm.
I don't know.
And I feel like this also ties back to whether or not a field can ever prove everything. Just like a field cannot prove itself,
Right.
it, it's limited. It cannot prove itself. It cannot. And although we can use things like math to prove greater and greater things, what was the theory you were telling me about in another
What was
conversation?
that wasn't Gödel's incompleteness theorem, was it?
Yeah, I think it is
There's
actually.
or a different theory of dual aspect monism.
No,
Is that
Gödel's
what you're referring to?
incompleteness theory, that
Oh
no
yeah,
matter what, we can't prove that we have proven everything.
yeah. At some point, basically all of your axiomatic systems have to pull themselves up by their own bootstraps.
Right.
Like,
And no matter how up they've pulled themselves, we can't say that they've proven everything. There's always,
no,
maybe Einstein said it something like, there's always more than what we know.
yeah,
Just because we can prove more than we used to know doesn't mean that we've proven everything.
that's true. You can only have degrees of confidence in your knowledge, and you're especially confident when different fields that you're studying within start touching other fields and creating this consilient theoretical
Mm,
field that shows, okay, by the very fact that we've started from all these different points, we know we're probably studying the same thing if we all end up describing the same thing with our separate disciplines. And that can give us a lot of confidence that at least the method we're using is on track. We can never prove the foundations of our theories, but we can be confident in our methods.
right. I just thought of a little concrete example as the consilience between music and mathematics, where
Hmm.
we can recognize that octaves sound good together. There's synchrony, and we can see how sounds that are in sync can exert greater physical force on objects. And then we can tie that to the
Yeah.
mathematics, the physics of it. So this is just like a concrete example of consilience.
Yeah, you can get feedback, for example, if you can create a resonant frequency that matches an external object, and you have extra confirmation that that external object is there if you can match the resonant frequency of, say, a wine glass, for example, and shatter it. Like, yes, you know that your theory of sound matches your theory of the resonant frequency of that object. And so that just adds extra confidence to your belief in the external world.
Exactly. And so we cannot say that mathematics is absolute truth. I mean, even though a lot of people would be comfortable with saying that math is absolutely true, but we can't, just like we said, um, a field can never prove itself beyond of a shadow of a doubt to be absolutely true, because every no field can prove itself. But the fact that math can absolutely accurately predict and explain and justify things like resonant frequencies, and it's so useful for creating the field of physics as a whole, and describing music and describing art and everything,
Yeah.
just goes back to what you were saying, that the value, there's value regardless of whether we can prove it true beyond a shadow of a doubt. It's at least we can prove it's valuable.
Yeah, I think that's probably right. I well, the problem I see with mathematics is, and we may be getting on a tangent here, but the issue with mathematics, and this I think does tie back in with paradoxes, is that unless we can confirm that the universe is digital, I think that the concepts that math deal with are too ideal to describe what could be an analog or fundamentally random universe. If it is true that the universe has a fundamentally random origin, and it certainly seems that things in organic nature are analog, they're continuous. It's like comparing a sundial to a digital clock. Like the sundial is ironically always going to be more accurate than a digital clock, because
Oh,
it gives
wow.
you a real-time, real-world feedback of where the sun is in the sky, whereas digital parses things up into discontinuous units. And so mathematics seems to slice the world up into pixels in discrete units, whereas maybe the world is not divisible into discrete units. And so maybe mathematics has that problem of being too ideal to be real.
Oh, wow. Great. I feel like there's one thing missing. If we don't talk about this, we've missed something.
Hmm.
We're talking about randomness. And so the one thing I haven't yet mentioned is quantum randomness.
Oh yeah.
What do you think about that? First, define it. Define it.
Okay. Well, I don't think anyone has confirmed whether or not quantum particles behave randomly, but we do know they behave chaotically at least. There, from what I understand, listening to various physicists, there is a quantum, what did they say? In quantum field theory, there seems to be a field of virtual particles where there are particles and antiparticles which can apparently pop in and out of existence. And when a particle meets another particle, it connects with that. But if a particle meets an antiparticle, they cancel themselves out and disappear again. And so you have this teeming sea of particles and antiparticles popping in and out of existence and connecting with each other and creating clusters and other areas canceling themselves out. And when we do experiments, well, when they do experiments with like the double slit experiment to show quantum indeterminacy, that that there's this interference pattern before you observe it, but then when it is observed, you just see the two slits. There are various interpretations about that. The most popular one is the Copenhagen interpretation. I don't know enough about quantum mechanics to give anything definitively interesting, but it seems that Gnostic ideas of the pleroma, Taoist ideas of the Tao, and quantum mechanical ideas of the virtual particle field seem to have something in common, whether or not they
Yeah.
are literally isomorphic to each other. That has yet to be determined.
Fair enough. Well said. There's that overlap. There's that um, commonality between these very different disciplines. I think like every discipline uses its own language. That's how I like to think about it. Every discipline uses its own analogies, its own
Jargon,
visualizations, uh, and and
jargon.
and huh?
Every discipline has its own jargon.
Jargon. And so
Yeah.
when these different disciplines end up corresponding to each other, having something in common, some overlap, there might we might call that consilience in a
Yeah, we might be talking about the same thing.
that's cool. That's crazy, right? So uh let me say a little more on quantum indeterminacy. Uh I forgot the big name, but
Copenhagen,
no. When it on the topic of quantum electrodynamics, I think the guy's
Niels
name starts with
Bohr,
an F. Fine something.
Faraday, Feynman.
Feynman. Thank you, Richard Feynman. Has so quantum. The quantum world is very indeterminate from
Yes.
our standpoint, at least. And yet, what Richard Feynman has done is he's constructed this this mathematical theory to describe this indeterminacy in a way that
Hmm.
constrains it to a not exactly predictable but more predictable uh, give us a more predictable
Sort of a
picture, almost an
gives you a
explanation.
defines it as a set of probabilities.
Exactly. A set of probabilities, basically like a mathematical theory of the pleroma, if I could
Okay, yeah.
tie
What
it
what
to
are the
that other.
most likely what are the most likely outcomes of the behavior of the pleroma?
Exactly. So
Interesting.
so we might not be able to mathematically with mathematical precision describe indeterminacy or randomness from our vantage point in precision, but we're trying.
Yeah, the thing about randomness is that you can never know when you've discovered it. You can only fail to describe it. And so the idea of randomness has this annoying quality of sounding like a God of the gaps argument.
Yeah, the
Like I
unknown, the
can't
great unknown.
I can't explain it, therefore God did it. I can't explain this, therefore it's random. Like I want to avoid that territory, but I'm trying to be as serious as possible in asking the question, is it possible that true randomness does exist in some sense? And is it the field, is it like the background surrounding field within which all this order we have is nested within? And anytime we have a problem with grounding any of our disciplines, is that grounding, uh, does it owe its, uh, is what is outside our grounding problems a field of randomness?
Mm,
I guess is my question.
yes. Whew, wow. I don't know if we can
That may be impossible to answer.
I don't know if we can put our hands around randomness, you know? I don't know if we can grab onto it and say, now in this conversation we have grasped randomness. As
No,
randomness
because by
is,
definition, it's ungraspable.
oh, exactly. By definition, we are trying to define and understand by defining
Mm-hmm.
this undefinable aspect of our universe that seems to grow out of who knows what. And so I feel like
Yes.
that might sort of con- be a way to conclude.
Yeah, that's food for thought. I'll leave you all with, we could leave you all with that. Think about, does randomness exist?
Man, so much food for thought. I think we just handed our listeners and viewers a big old smorgasbord of ideas to fill up and explode on. I feel my brain is just like grown outside of its skull to try to describe and map any of this stuff. So
Yeah, keep your psychologists close at hand for any of your aneurysms and mind explosions you may be at risk for.
hopefully we didn't uh, pop any heads. So anything else that we should say before we wrap up here?
Not that I can think of. I just want to let all the viewers know that this is a highly experimental episode. We, at least I, have not articulated my mind as clearly as I should or possibly could.
We're doing all of this on the fly, and I think we're going to do this all on the fly every time. We're basically showcasing two brains wrestling with difficult things for your entertainment, for your mental stimulation, right?
Yeah, and we'll try to discover new topics and touch on different ideas and try experimenting with other ways of thinking that hopefully you'll find interesting.